without further ado, I'll begin recording. So, calculus with parametric curves. This essentially is going to be when we're dealing with t and stuff like that. We want to get x and y in terms of t, and from that we're going to do different things with that. An example of a question that we may do with that is say, okay, we're given x equals something, y equals something, and then we want to find an equation for the tangent to the curve in terms of t. So what we would do then, we would take derivatives with respect to t of y and x and go from there. You saw a question similar to this on the homework. Next, if we get into the 3D coordinate system, what we're going to be looking at a lot with that is sketching surfaces, finding distances to our xy axes, our z axis, yz axes, all our axes, and then we may want to find the closest distance to the just x axes or whatever, which would be x equals 0, stuff like that. And that's pretty much about all you've seen there. Next, we get into vectors. So vectors, a lot of different things we can do with vectors. One of the things we can do is we're given 2 points, P and Q, and we want to find a vector represented going from P to Q, and we want to find a vector representation of those 2 points. We can do stuff like that. What else do they have you guys do? I'm taking a look real quick. They also have you say, okay, what vectors are equal, parallel, projection of vectors, adding vectors, stuff like that. Finding same direction with vectors as another vector, finding unit vectors, all that good stuff. The last thing that you guys went over today was dot product. And dot product, a lot of is just multiplying our components together. And that's pretty much about the only thing you get into. You get into a lot of wordy stuff with that. But in essence, you're just multiplying your vectors together. So without further ado, what I think we'll do is we'll kind of start with calculus. For the assignment that's going to be due tonight is calculus with parametric curves. So if we look at, or I'm sorry, wrong one. The 3D coordinate system, apologies. So if we take a look at the 3D coordinate system, we're thinking about 12.1. And a question that you may see in 12.1 could be something like, okay, let's find an equation. A lot of times what you're going to do is you're going to be given, let's say, a sphere. So we want to find the equation of a sphere. And our general formula for equation of a sphere is just going to be x minus b, or that should be an a, x minus a squared plus y minus b squared plus z minus c squared equals radius squared. Okay, so from here, what we can do is we can say, okay, they give us 2 points, and they say find an equation. Let's say they give us a point. They say the sphere is going to pass through point 2, 5, negative 3, and it's going to be centered at 1, 6, 1. Okay, so right away, when we say centered at, we found our A, B, and C. So this x component relates to A, the y component relates to B, and the z component relates to C. So if you think back to some algebra 1 and 2 stuff we would have done manipulating equations, same exact thing. So we can start writing this equation as x minus 1 quantity squared plus y minus 6 quantity squared plus z minus 1 quantity squared. Okay. And now we need to think about our radius squared. To do that, we need to find the difference between all these points and find the distance we're going in x, y, and z. And to find that radius squared, what we're going to do is we're going to take each term squared. So what I like to do is okay, let's do 1 point minus the other point. So let's do 2, 5, 3 minus 1, 6, 1. And if I do that, that's going to give me a distance in my x, y, and z. That's going to leave me with a point 1, -1, 2. Oh, I'm sorry. 1, -1. That should be a -3. My bad. And that'd be a -4. Apologies on that one. So then what we're going to do to find our radius squared equals the square root squared of every individual term here. So we'd have 1 squared plus -1 squared plus 4 squared. And if we do that, we see here that we have a square root squared. So this square root's going to cancel with that squared. Then we're just left with r squared equals 1 plus 1 plus 16, or r squared equals 18. From there, we can finish writing our equation. We have x minus 1 quantity squared plus y minus 6 quantity squared plus z minus 1 quantity squared equals our radius squared, so equals 18. Okay, so that is one question that you may see. Another question we may see that we could get, and I apologize, guys, this camera is not the best, so if you need me to do anything, zoom in or anything, speak up, please, or whatever. I realize it's not the best, just kind of bear with me with this. But another thing we may see is we may be given a point. Let's just say we're given a point, and I'm just going to make something up here. 4, 7, 9. Okay. And from here, what we want to do is we want to find projections onto every plane. What I like to say when we find projections onto every plane is whatever variable is not included, we're going to make 0. So let's say that we want to find projection onto the XY plane. So since we're XY plane, I'm going to say that z equals 0. And from that, our projection then would be 4, 7, 0. And similarly, if we said onto the YZ plane, then we're going to say x equals 0. So then we'd have 0, 7, 9. And again, similarly, let's say we said the XZ plane. We would say y equals 0. So then we'd be left with 4, 0, 9. So another possibility for questions you could be asked. Now, with this same point, they can ask us some more questions. Let's say that we're given point 4, 7, 9, and we want to find the distance let's say first to the XY plane. So if we want to find the distance to the XY plane, we're saying that z has to equal 0. So from this, we have to get our z component to be 0. So to do that, what we would do is we would have this point, considering only our z's because we want to get to the XY plane. We're going from 0 to 9, so the distance then would have to equal the change in z, which is equal to 9. Similarly, let's say we say to the YZ plane. So now we need to think about x. So x is equal to 0. That distance between those 2 points is going to be 4. And then similarly, you could see if we had the XZ plane that distance would be 7. Now, Another interesting thing that they like to do is they say, okay, well, let's find distance to the x-axis. So if we want to find that point, what we're going to do is we need to find the distance between 2 points now, not just the distance of components. Thinking about what line's going to give us the closest distance to the x-axis, we need to think about something perpendicular. Something perpendicular is going to give us the same x value. So if we do that, and here we're going to have some other point with 4, and then we're not going to change our y or z, because if we change our y or z, we're just going to increase our distance, and we don't want to increase that distance. So we'd be left with 4, 0, 0. Now what we need to do is we need to subtract these points. That's how we're going to get that distance. And the distance is the square root of these 2 points subtracted squared. So let me kind of show you what I mean here. So we would have 4, 7, 9 minus this would give us 0, 7, 9. To find distance equals the square root of every term squared. So we'd have square root of 7 squared plus 9 squared plus 0 squared. And if we do that out, it's 49 plus 81 gives us square root of 130. Okay. So now similarly, let's say we wanted to find the distance to the y-axis. So again, that closest distance is we're not going to change our y. So we would have a point 0, 7, 0. And then we'd have minus our original points. We'd have 4, 7, 9 minus 0, 7, 0 would give us 4, 0, 9. So the distance would equal the square root of 4 squared plus 9 squared, which I'm not going to do out. So similarly, if we did the z-axis, we would find that point 0, 0, 9, subtract that from our original point, and use that same formula to find what that distance would be. So one of the big things to remember from this section is distance is the square root of each component squared. The square root of the sum of each component squared. How about that? So now that pretty much covers a majority of what you would see in section 12.1. Next, we're going to go into a little bit of dot product work. I know you guys started this today, so we'll just kind of go very tentatively into it, not do anything crazy. And then from there, if you guys have questions, definitely ask. If not, you guys will all be free to go. Like I said, I don't have a ton of stuff for you today, but I do have some. So let's start off, kind of get y'all warmed up again, seeing it again. Let's say we have two vectors. We have A equals 1, 4, and B equals -2, 0. Sure, we'll go with that. Okay, so I want A dotted with B. A dotted with B equals 1, 4 dotted with -2, 0, which equals 1 times -2 and 4 times 0. So we have 1 times -2 plus 4 times 0, which equals -2. Okay, so one thing to know about the dot product is A dotted with B does not equal, it does equal excuse me. So that is going to be the case, and that's, I know it's hard to see, but A dot with B equals B dot A. That's not going to be the same for cross product. We're not going to get into that. But cross product, A crossed with B does not equal B crossed with A. So that's kind of just a warm up to what we got going on for this section. Now what we can do is we can think about another example that they're going to give us is saying, okay, well, let's find some angle between two vectors. Now you're going to be given an equation, so angle between two vectors, we're going to have the cosine of theta equals A dotted with B divided by the magnitude of A times the magnitude of B. Okay, so putting this into practice, let's say we have A equals 1, 1, 1. We'll have B equals 4, 3, 2. Try to keep my numbers easy here. So I like to start these by finding the magnitudes first. So if we find the magnitude of A, it's simply the square root of each term squared. So magnitude of A equals square root of 1 squared plus 1 squared plus 1 squared, which equals the square root of 3. Magnitude of B equals the square root of 4 squared plus 3 squared plus 2 squared, which is 16. 25 equals square root of 29. Okay. So now we have the two bottom parts of this. Now we need that top part, A dotted with B. We do A dot with B, we're going to have equals 1 times 4 plus 1 times 3 plus 1 times 2. Take that first term times the 4, second term times second term, third term times third term, so we would get equals 9. So then from here we'd have cosine of theta equals 9 divided by square root of 3 times the square root of 29. Okay. Then from there, what we can do is we would take cosine inverse to find theta. So you'd get cosine -1 of 9 divided by square root of 3 times square root of 29. And that would be your theta angle. All right. Another thing that we can do is we can think about projections if we want to. We can think about a bunch of different things. Yes, yep. So if I was to draw two vectors, good question. If I was to draw two vectors, and let's say I'm going to make this A, I'll make that B actually, because that makes more sense. And this A, that value there is theta. You got to think about it in 3D. It's kind of weird, but yep. Yep. Good question for sure. So yeah, let's do one where we're going to find projections of vectors. So what we do here is we're going to start with something that, let's just say we're given a problem statement that looks something like, find the scalar and vector projection of B onto A. So I'm going to go to a different sheet of paper. Say we're given two vectors, A equals -3, 6, 2, and B equals 3, 1, 3. We want to find the scalar and vector projections of B onto A. So scalar projection, what that looks like is that's going to be the comp A of B. And the way I like to think about this, the way I like comp, I forgot my P. Let's try again. Comp of A So the way I like to think about this is B sits above A, so we're looking at our projection from B onto A. Okay, so essentially what we're saying for that is we have something, and what we need to do is we need to find our magnitude of A, which we got to find a couple things, but essentially our scalar is going to be A dotted with B divided by the magnitude of A. And that will be our scalar projection. So what we have here is we need magnitude of A. The magnitude of A, if we do it real quick, is going to equal square root of 9 plus 36 plus 4, which is equal to the square root of 49, equals 7. And then A dotted with B equals -9 plus 6 plus 6. It's going to equal 3. So if we combine those two, we'd say comp of B onto A equals A dotted with B, 3/7. Okay. So next what we have is we're going to have then our projection. So a vector projection now is vector. Vector projection, we think about, it's very similar to this. We just have projection, project, of B onto A. So that's different. If we're thinking about a scalar, we're thinking about comp. If we're thinking about vector projection, we're thinking about proj. And that is going to be the difference. So don't get those mixed up if you see them on an exam or something. But the general formula for this then is equal to comp of B onto A times A divided by magnitude of A. That may be kind of hard to see. You can try and zoom in a little bit more. That helps at all. Okay, so we already know what this is. We know that is 3/7. We know what the magnitude of A is. The magnitude of A is 7. Now we're just left with A, so let's just plug everything in. So what we have is we have equal to that first part, 3/7 times A divided by magnitude of A. Well, let's pull that magnitude out front. We have 1/7 times our vector A, which is -3, 6, 2. And if we wanted to simplify that, this would become 3/49 times -3, 6, 2. This here is a numerical answer. This here is a numerical answer, so both of those are correct. But you can also do them out the rest of the way. And if we do it out the rest of the way, we'd get projection of B onto A equals -9/49, 18/49, 6/49. Okay, so that pretty much covers everything I have for you guys. Did I miss a question in the chat? Let's see. No, I did not miss any questions. So if you guys have questions, now's the time to ask. If not, you guys are free to go. That kind of covers pretty much everything from the sections. So yeah, no more questions, free to go. If you have questions, feel free to ask them either in the chat or you can speak up, whatever you guys want to do. I'm just going to mute myself and you're free to go if you don't have questions.